probability, and we want to consider some examples. We are given two events A and B, and the probability of A is 0.3, probability of B is 0.5, and probability of negation of A intersection B is 0.35. So we want to determine whether events A and B are independent or not. Then what we know is that probability of A intersection B would be probability of A times probability of B. So that's something that we want to keep in mind, that when they are independent, that's how we get their respective probabilities. We know that probability of A not A should be 1 minus probability of A, which is 1 minus 0.3, which is 0.7. Therefore, what you're basically saying is that probability of A intersection B independent if this is true. And from what we have been given, we are told this is 0.35 and this is 0.7 times 0.5. and this is 0.35. So because that is true, then it's very easy to tell that the two events are independent of each other. So we can comfortably say that event A and B are independent. So that's something we want to keep in mind as we calculate the probabilities. We are told to find probability of A union B, and since we don't know much about the issue of independence here, we can write probability of A union B as probability of A plus probability of B minus probability of A intersection B. And since we know that A and B are independent, it will be 0.7 plus 0.5 minus 0.7 times 0.5, and this is 1.2 minus 0.35, and this gives us 0.85. So that is the probability of A union B. Second example, our second example, a single fair dice is loaded. So we have a number of questions. We list the sample space for a single dice, and S is all the numbers that are equally likely to occur. And so in our second example, the first part you have shown the sample space, the second part you are told to let event A be equals to all the even outcome and event B to be the outcome divisible by 3. So probability of A will be all the numbers. You have 2, 4, 6, which is 3 over 6, which is a half. And then probability of B are all the numbers divisible by 3, which is 3 and 6, which is 2 over 6, which is 1 over 3. One of them is we want to find probability of A intersection B. Remember that A is equals to 2, 4, 6 and B is equals to 3 and 6. So that is what we have, and therefore I can comfortably say that A intersection B should be equals to 6. So probability of A intersection B is only one element out of the total number of elements that exist, and which is equals to 1 over 6. They are only independent if probability of A intersection B is equals probability of A times probability of B. And since it's 1 over 6, we saw this is a half times that, which is also 1 over 6. Thus, A and B are independent. So number 3, a problem is given to 3 people, A, B, and C, whose respective chances of solving it are 1 over 5, 1 over 3, and 2 over 5 respectively. What is the probability that the problem is solved? So the probability of the problem being solved will be equals to 1 minus the probability that it is not solved. And since the probability of solving for each of the person is independent of the other, then we can write this as 1 minus the probability of A not solving it is 4 over 5, because the probability of solving is 1 over 5. The probability of B not solving it is 2 over 3, and the probability of C not solving it is 3 over 5. And therefore when we cancel, it will be 1 minus 8 over 25, which is equals to 17 over 25. So there is a 17 over 25 chance, or if you wish we can write it, there is a 68% chance that they will solve the problem. For number 4, we are told that out of 200 students in a school, 60 play cricket only, 80 play football only, 55 will play volleyball only, and 5 play no games. And when you look at 60 plus 80 plus 55 plus 5, that should be equals to 200 students. So one student is picked at random. What is the probability that he plays volleyball? Therefore, probability of volleyball should be the number that play volleyball, and we can see that they are 55 divided by 200, which is 11 over 40. So that is the probability that a student plays volleyball in the school. He plays he or she either plays cricket or volleyball. So it's take the number of those who play cricket and the number that plays volleyball, divide by the total number of students, which is 115 over 200. And if we divide by 5, this will be 23 over 40. So there's 23 over 40 chance that a student will play cricket or volleyball. So plays cricket nor football, it will be 200 minus 60 minus 80 over 200, which is 60 over 200, and that is by 23 by 2010. There is a 3 over 10 chance that he plays neither of the indicated games. If at least one child in a family with 2 children is a boy, what is the probability that both children are boys? So what the question is telling us is that this family has 2 children. So want to put down the sample space. They could both be boys. They could be both be girls. We could have the firstborn as boy and the second one as a girl, or the firstborn as a boy and the second one as a girl. And so we have 3 outcomes. So the probability that both are boys is the probability of a boy over the total possible outcome. Therefore, the probability that both of them are boys is 1 over 3. If you love my videos, which I'm sure you are doing, please press the subscribe button. Thank you.